Section 1.1, problem 5, on page 6, we have you can simplify an algebraic expression by combining the parts of an expression that are alike. In an algebraic expression, a term is a number, a variable, or the product of a number and one or more variables. A constant is a term that has no variable. A coefficient is a numerical factor of a term. Rewrite expressions as sums to identify these parts of an expression. Notice we have 6a squared minus 5ab plus 3b minus 12, and we're just rewriting these with plus signs in the middle of every term so that we can identify the coefficients and the constants. So in 6a squared, the 6 is the coefficient and a squared represents our variables. Then we have, instead of minus, we'll say plus negative 5. So negative 5 is our coefficient here, a and b are the variables, plus 3b, where 3 is the coefficient, b is the variable. And then we have plus negative 12 instead of minus 12, and negative 12 is the constant. In the algebraic expression, 6a squared minus 5ab plus 3b minus 12, the terms have the coefficients of 6, negative 5, and 3, and the term negative 12 is a constant. Notice every time there is a break, so whether it's a minus or a plus, that gives us a new term. On page 7, we also have like terms have the same variable factors. To identify like terms, compare the variable factors of the terms as shown below. So if we have the terms 4x squared and 12x squared, the variable factors are x squared and x squared. So yes, those are like terms. Over here we have 6ab and negative 2a. This has a variable term of ab, and this has a variable of just a. So no, these are not like terms. Here we have xy squared and x squared y. Be very careful. This has the y being squared, this has the x being squared. Those are not the same, so they are not like terms. An algebraic expression in simplest form has no like terms or parentheses. So 2 times the quantity 3x minus 5 plus 4x is not simplified because this 3x plus 4x could be combined as like terms, and then we would need to distribute this too. 14x minus 10 has no parentheses, and I can't combine the 14x and the 10 because there's an x here and there's no x here. So you can use the distributive property to help combine like terms. Think of the distributive property as BA plus CA equals B plus C times A. To get an idea of what we're talking about, example number 5 says, what is the simplified form of 8x squared plus 2x squared? So the way I like to look at this, I highlight the variable terms that match. So x squared and x squared, think of them as something else. Think of them as apples or Skittles. I would say I have 8 apples, and then I have 2 more apples. So altogether, 8 plus 2 gives me 10. And what did I have? Well, I called them apples, but they were x squareds. So that just becomes 10x squared. And to highlight that even more, I'll highlight the 8 and the plus 2 to give you the 10 for 10x squared. Same idea for part B. What is the simplified form of 5x minus 3x plus 6y plus 4? So now we have more than just one type of term. Up in part A, they were both x squared, so we just combined them. Not all of these can be combined. So let's start with the x's. We have 5x, and then I have a minus 3x. Notice I'm going to keep that negative sign with it. That goes with the term. I don't have any other x's that are just x, and that's all I can combine. So I say 5x minus 3x is the same as saying 5 minus 3, or 2, and then x. Normally we like to put the variables first. So my next variable that I have is a plus 6y. There are no other y's. So I can go ahead and just write plus 6y. And finally, we have some constants of minus 3 and plus 4. Those ones you just add normally. So 4 minus 3 or negative 3 plus 4 gives us positive 1. So our final answer here would be 2x plus 6y plus 1. All of that work is on these next few slides, which you can go through on the slides on Google Classroom. And now I would like you to try homework number 9. So simplify each expression by combining like terms, negative 7h plus 3h squared minus 4h minus 3.